Graphical methods of solving linear programming problems. In the previous video, we discussed the formulation of a linear programming problem in the form of inequations to maximize or minimize a linear function of the variable subject to some constants. Now the question is, how do we solve such linear programming problems? The most common method used to solve a linear programming problem is the graphical method. To understand this method, first consider the inequation x greater than or equal to 0 and y greater than or equal to 0. We know that x greater than or equal to 0 represents a region lying towards the right of the y-axis, including the y-axis. Similarly, y greater than or equal to 0 represents a region lying above the x-axis, including the x-axis. If we combine both x greater than or equal to 0 and y greater than or equal to 0, then the region common to both will be the first quadrant, including the positive side of the x-axis and y-axis. Now consider the inequation x plus 2y less than or equal to 8 and x plus 2y greater than or equal to 8. The graph of equation x plus 2y equals to 8 looks like this. The graph given by x plus 2y less than 8 lies towards the side of the line x plus 2y equals to 8, in which the origin is situated, because any point in this region will satisfy the inequality. Therefore, the shaded region in this graph represents x greater than or equal to 0, y greater than or equal to 0 and x plus 2y less than or equal to 8 simultaneously. Similarly, if we have to consider the region bounded by x greater than or equal to 0, y greater than or equal to 0 and x plus 2y greater than or equal to 8, then it will lie in the first quadrant and on that side of the line x plus 2y equals to 8, in which the origin is not located. Therefore, the shaded region in this graph represents x greater than or equal to 0, y greater than or equal to 0 and x plus 2y greater than or equal to 8 simultaneously. Now consider the inequation x greater than y. The graph of the equation x equals to y looks like this. The graph given by x greater than y represents a set of all ordered pairs where abscissa is greater than ordinates. Therefore, the shaded region in this graph represents x greater than y. Now let's understand some terms related to the graphical method of solving a linear programming problem. The common region determined by all the constants, including non-negative constant x greater than or equal to 0, y greater than or equal to 0 of a linear programming problem is called the feasible region or solution region for the problem. The region other than the feasible region is called an infeasible region. A set of values of the variables of a linear programming problem which satisfies the set of constants and the non-negative restrictions is called a feasible solution of the problem. Graphically, it is the set of points within and on the boundary of the feasible region. A set of values on the variables of a linear programming problem which do not satisfy the set of constants and the non-negative restrictions is called an infeasible solution of the problem. Graphically, any point outside the feasible region is called an infeasible solution. A feasible solution of a linear programming problem which optimizes its objective function is called the optimal solution of the problem. Graphically, any point on the feasible region that gives the optimal value, maximum or minimum of the objective function is called an optimal solution. Using this method, we can easily solve a linear programming problem.